Welcome! In this video, we will explore the fascinating concept of the span of two vectors in a two-dimensional space. Let's dive in. Let's start by considering two vectors, v1 and v2, that point in different directions. Here, we'll use the yellow vector, v1, and the red vector, v2, to explore what their span looks like in the plane. When two vectors are independent, any point in the 2D space can be reached using a linear combination of these two vectors. A linear combination means scaling v1 and v2 by some real numbers and adding them together. Watch as we adjust the scalars. The green vector, our resultant vector, changes direction and magnitude, reaching different points in the plane. Each dot marks a position we've reached using a unique combination of v1 and v2. Notice that no matter how the scalars are adjusted, v1 and v2 never change direction. Even if the green vector moves in the opposite direction, it is still a linear combination of these two vectors. The span of two independent vectors is the entire 2D plane. This means that with the right scalars, you can reach any point in this space. These two independent vectors form the basis for the plane. Now, let's consider a different scenario. What happens when two vectors point in the same direction? Here, we have v1, shown in yellow, and v2, shown in red. These two vectors are dependent because they lie along the same line. To simplify the animation and enhance visualization, the vectors are depicted side by side to clearly demonstrate their behavior. However, in reality, all three vectors move along the same line. This approach is solely for clarity and does not alter the underlying concept. When two vectors are dependent, their span is no longer the entire plane. Instead, the span is just the line on which they lie. No matter how you scale v1 or v2, the resultant vector will always remain on this line. Even though we can scale these vectors positively or negatively, their span remains limited to this one-dimensional space. Unlike the previous case, we cannot reach every point in the 2D plane with these two vectors. To summarize, when two vectors are independent, their span covers the entire 2D plane. However, when two vectors are dependent, their span is limited to a single line. This fundamental concept of vector span is key to understanding higher dimensional spaces and forms the foundation for linear algebra. Thank you for watching, and happy learning!